Good morning and welcome back to the Thermodynamics chapter basics. Now, yesterday we have seen heat of formation, which is nothing but in special case of a heat of reaction, and calcium carbonate is exemption. Means the heat of formation it should be 1 mole, and another one is it should be from its constants. Now, some more varieties of the enthalpy we will see. Before going to the some more enthalpies like enthalpy of the combustion or enthalpy of the atom, enthalpy of the nucleation, all these things. Before that, one small law, Hess law, that is the most important and many times coming into the questions. We'll see. Hess law is nothing but whether a reaction is taking place in one step or reaction is taking in a more number of steps. The final ultimate value of the enthalpy of reaction is same. That in simple words, A to Z is the product. Means A is the reactants and Z is we are reaching to the Z stage. This enthalpy reaction is some heat of reaction. Enthalpy of the reaction is 1. It is equivalent to, if I am going to A to B, from B to C, C to Z, this also same. Means this is another root of the root. So the first root and second root the doesn't change. It depends upon only the states, means initial and final. So the definition what is the total enthalpy change of a reaction is same whether the reaction takes place in a single step or in a several steps. That is the one Hess law. Normally the people ask the question. Now most important one in the problems is coming as a enthalpy of combustion. Enthalpy of combustion. So how it is different we will see. This symbol what we are writing normally is combustion. C standard condition is minus. Top. See, we have seen already heat of reaction, standard condition. We have seen formation, how it is different and all. Now one more term is enthalpy of the combustion at standard conditions. How it is different. It is just simple when see the products we are not worried. In the reactant it should combustion. Combustion means it should react with oxygen. Standard enthalpy of combustion is defined as enthalpy change per mole, again 1 mole of a solution when it undergoes a combustion, all the reactants. Simple reaction is carbon plus oxygen CO2. In this case, this fulfilling all the three. Chemical reaction also the same, heat of formation is same, it is a combustion also. Because it is a constant formation, because it is in the oxidation, it is a combustion. It is reactants means products or reactants minus reactants heat of enthalpy, products enthalpy minus. So, but in some other cases we will see how it is different and all. For example, our LPG gas, that is butane, 99% is butane, 98% C4H10. If I am reacting with oxygen, that is the non-balancing equation, 4CO2 plus 5H2O plus delta C combustion is H equal to some minus 26,658 kilojoules per mole. See, so what we want to say is finally it should react with oxygen and it should be for 1 mole. 1 mole of the reactant. Then that is combustion. There will be so many problems and all. We will see problems one by one. Then atom and all tomorrow we will see. Now some basic, some small problems. A simple, first start with a simple problem. The problem is nitrogen is reacting with hydrogen, gives ammonia, 2NH3. In this, heat of formation means delta RH minus equal to minus 92.4 kilojoules per mole. This is heat of reaction. Now, if I want to say for the same thing without giving anything, how much is the heat of formation? That is normally the multiple choice question. What is not there in this? It is formed from its constants. So this is a formation only. Why it is a reaction? Reaction is because here is the 2 moles. If it is 1 mole, it would have been the same. So if it is the heat of formation, if I want simply, it is FH minus equal to 50% of this, some 46.2. Very simple. This is the most of the time. Otherwise, if he is giving this equation and if he is giving same thing, suppose same value is giving and the half, both sides half if he is making, then heat of reaction equal to heat of formation. The next question we will see. The bomb calorimeter, we have seen the enthalpy and the internal energy. Internal energy was given for one of the compound is ammonium cyanide, NH2CN. It is a gas. Here it is a gas is most important, and oxygen, it is also again gas, gives to nitrogen plus carbon dioxide plus water. Delta U is given. Delta U is equal to minus 742 kilojoules at 298. At 298. And he is asking the how much is the delta enthalpy H. Simple equation we know, delta H equal to delta U plus delta N RT. Delta U is given, delta is asking, delta N always remember it is nothing but gaseous products, number of moles of gaseous products minus number of moles of the reactants. Here it is 1 plus 1, it is a liquid, H2O is a liquid. 1 plus 1, 2, here it is 1 plus 1 and half, 2 and half. Delta is 2 minus 2 and half. Products is only 2, reactants is this thing. Delta U is already given. So R is already known, that is if it is in joules, it is 8.35 joules and temperature is 298. Calculate, that will be something, it will be almost, because it is in joules and this is in kilojoules, so 7 minus 742, this will be the same value. So calculate, that will be the next answer. Then one more question we will see. Calculate the number of kilojoules of heat necessary to raise the temperature 60 grams of the aluminum. 60 grams of aluminum is taken, and he wants the temperature raised from 35 degrees to 55 degrees centigrade. Very simple, I will tell. Molar heat capacity of aluminum is 24 joules per mole per degree Kelvin. Here 24 joules per mole he is giving, whereas 60 grams aluminum. So immediately I have to convert into the number of moles. So aluminum is 26 around 27. So 26 is the number of moles. Cp was given as 24 joules, and temperature raise, don't worry about the converting into the Kelvin and all. Once it is a differential temperature, when we are taking, whether we are taking into the degree centigrade or Fahrenheit or Kelvin, not much different. Fahrenheit and Kelvin. So here it is 20. So in the Kelvin also it will be 20 difference. Delta T we have to write. So 20 degree Kelvin. This is the answer. Roughly it will be in the if you converting into the kilojoules, it is all joules. So it will be almost 20, 24, 60. So one that means around 1000 joules. Nothing but around 1 calculate. So that is the next problem. One more problem we will see. We want to go for the first slightly the completing the more number of problems in less time. Enthalpy of a combustion of carbon dioxide is given. Carbon dioxide is given as minus 393 kilojoules per mole. Calculate heat released upon formation of 32 grams. So immediately you have to write formation of oxygen means carbon dioxide means C plus O2 equal to CO2. This is 1 mole. So formation, this is given as the heat of the enthalpy is 393.5 kilojoules. But the question was given as the number of moles he has converted. This amount is 35.2 grams. So, but our formation equation is the for 1 mole. So immediately we have to convert into the mole. CO2 is 16 32 plus 12 44. So 44 I am dividing, and the for 1 mole it is 393. 35 to 44 is roughly around 0.8 into 393. 0.8 into 393 we have to see around it will be some 315 roughly. Minus sign is always because it is exothermic and it is kilojoules. That is the next question. So one more small problem we'll see, and then we'll stop. He has given the enthalpies of the formation of the CO2, N2O and N2O4 as was given, and the equation given is N2O4 reacting with 3CO given as N2O plus 3CO2. Then what will be the delta H reaction? We know the formula of delta H reaction is products minus reactants formation enthalpy change. So immediately what we have to write? Products means N2O value, then 3CO2 value minus N2O4 value plus 3CO value is given to be given, and values are given is if you substitute the values, yes, you will get the answer. But only thing is whatever the value given to the CO2 you have to multiply with the 3, whatever the value given for the CO you have to multiply with the 3. So that will be the value for delta H, delta reaction H minus for above reaction. So they are very simple, but the most of the time what we are getting in the this thing in exams and all, most of the time, one question is a 100% guarantee question is giving the one equation enthalpy and equations for formation was given. So you have to, from formation you have to calculate the heat of reaction. Tomorrow we will see, and tomorrow we will see the other heat of those are not much important, bond and the neutralization and dilution or some things. Thank you.